Hello everyone, welcome back to Calculus 3. This part we will continue to study partial derivatives in section 4.3. This is how partial derivatives are defined, but anyway, usually we don't calculate partial derivative using definition, and we are going to use the rules we learned before. All the rules about derivative rules can be extended to partial derivatives, because if you see clearly and really the definition, it is for a regular derivative. Okay, partial derivative with respect to x, we consider y as a constant. Partial derivative with respect to y, we consider x as constant. So really, all those derivative rules still will work. And how about this time? Let's move on to the second part of the example. Okay, example 4.15. This is really from the textbook. And we did part A already. I suppose you feel very well. And how about let's take a quick look about part B. Part B. And still, we are going to consider partial derivatives. So accordingly, this time, the function is named as g. So we do have g sub x, and it is a partial derivative with respect to x. First, it is true, derivative sign tends to be cosine, so I got this part here. And also remember I said that the chain rule, right? Chain rule for derivative. And still the chain rule will work for partial derivatives. Okay, so that's from the chain rule, we will have to consider derivative from the inner part, partial derivative with respect to x. This cosine, it is from sine. Okay, then derivative of the inner part with respect to x. X squared y minus 2x plus 4. So derivative of x squared, that's 2x, y still stays. Derivative of negative 2x, that's negative 2, and combined with cosine. And also it is better just to move this term to the front. So people will not get confused if cosine it is applied to this thing or not. It is not. Cosine has nothing to do with the part in the front. Okay. And then partial derivative with respect to y, still, believe it or not, it is true. We are going to have cosine first. Then this time, we take the partial derivative with respect to y from the inner part, okay. What I'm getting here is, well, x squared considered constant, like 3y, the derivative is 3, 10y, derivative 10. So derivative of x squared times y is x squared. And then everything about x, this is the entire remaining part, that's a constant, according to derivative 0. So that is g sub y, This is the example 4.15, partial derivatives. And the way we calculate partial derivatives, we do use those old derivative rules, because partial derivatives are derivatives. That's all I'm saying. How about let's take a look at another example. That's from the textbook again. It's finding partial derivative, and I think probably still has part A, part B. Yeah, the second one it is has the name of the function is function g. So better put in words. Find partial derivatives. PAR. Find the partial derivatives. Still there are part A and part B. Okay, let's work on part A first. Partial derivative with respect to x. Notation wise, I suppose it's easy enough. We write this as f sub x, and it means df dx. Then you want to take a close look what this function is about for x. I'm seeing x in the denominator, right? And also there's x in the numerator. So would it make sense to you? This really should be considered as a quotient of two functions of variable x. Okay, so in the calculation of the partial derivative, this part I really use the quotient rule. And if you are not familiar with the quotient rule, this is the quotient rule I wrote here. I hope you do understand how quotient rule works, okay? And so basically I just use the quotient rule right here. Then I calculate the partial derivative, okay? Denominator squared stay the same. Then numerator prime, derivative numerator times the denominator, original denominator. And then this part would be uv prime, the original numerator times the derivative of the denominator, derivative of the denominator. And then let's take a look what I have. This entire thing it is from product rule, okay? So what I did in the next line, I just to try to calculate those partial derivatives. With respect to x, that's 2xy and minus 4z. This part just turns to be 0. Then similarly with respect to x, for this part, it is just 1 here. And certainly you can check with the textbook. I believe the textbook got the answer simplified. But anyway, for me, make it simple. I'm just going to leave all the simplification for you to finish. Because I think it's clear to me, to this moment, we have the derivatives taken very good care here. We got all the derivatives, derivative terms, and the quotient rule. Okay, f sub x. How about let's take a look at f sub y. F sub y, I say really it is about the same fashion. It is about the same fashion. df dy, I mean the quotient rule. And then for the inner part, we are going to take the partial derivative with respect to y and with respect to y again. And then I believe I should be all right. Partial derivative with respect to y. This term it is given x squared. This term in the middle has nothing to do with y, so that's a constant. That's a 0. Then partial derivative with respect to y. Now I just figured out, probably I did not get this part correctly. I think instead of x squared plus y squared, it should be x squared plus 2y. Product rule, okay, so this part stays the same and this part still stays. Then do partial derivative with respect to y. With respect to y, x turns out to be 0. With respect to y, turns to be negative 3c. And also you want to do some necessary simplification. I'm saying the simplification they are provided on the textbook. So if needed, do use textbook for reference, okay? And this time actually we have a function of 3 variables. So the third partial derivative, f sub z. But anyway, really in a similar fashion. Okay? And this entire thing take the partial derivative with respect to z, x squared y squared, they are fine. We're only having a term negative 4xz here. So the partial derivative would be negative 4x. And the second part, this same partial derivative with respect to z, that's a negative 3y. And also, as I'm saying, you want to consider further for the simplification part. And for me, mostly I'm just showing how you get partial derivatives. And that should be it about part A. Part B, the same requirement. Still, we are having a situation of a function of 3 variables. So accordingly, there's g sub x, g sub y, g sub z. And g sub x, well, g it is a function of 2 triggers, sine plus cosine. So really, well, using the sum rule, difference of a derivative sum, it is sum of derivatives, which really means we calculate each derivative term by term. So derivative sine tends to be cosine, and also we will have to handle the derivative from the inside part, inner part, with respect to x. So I'm getting this as 2xy, right? And sine tends to be cosine. I believe should be fine. This should be fine. Okay. And then similarly for the term of cosine, it's turning to be negative sine. And this is part, the derivative with respect to x. 2x I think that 2x, that's it, and minus 2x. And then you have those terms combined. Okay. And for the same function g, partial derivative with respect to y, in a very similar fashion like we just did a moment ago, then but those partial derivatives will have to be replaced with partial derivative with respect to y. So in this part, I'm having x squared, and in this part, I'm having x squared again. I believe partial derivative with respect to y. Actually, partial derivative with respect to y, that's x squared. Partial derivative with respect to y for the expression here. Okay, x squared is 0, and minus yc with respect to y, so that's minus z. With respect to y, that's minus z, I believe. Minus z. So finally, I got the partial derivative with respect to y together over here. And the last one, let's take a quick look if we can get the partial derivative with respect to z. dg dz, dg dz. Okay, similar arrangement, and this time you are going to have the function with respect to z, and the function with respect to z. With respect to z, for the first part, x squared y minus z, I'm believing I'm just having -1 here. -1 times cosine of that function. Then this part, partial derivative with respect to z again. I believe it's, let me try to see if I'm correct. Partial derivative with respect to z, this is -1. With respect to z here, it's -y, right? -y, so I'm having -y of sine of x squared minus y sub z, y sub z here. Actually, this is not a y sub z, sorry. This is just y times z, okay. Sine of x squared minus y times z. So I say mostly that's all about it. About the partial derivatives, you really need to control those notations very well. When you take the partial derivative with respect to one variable, treat other variable or other variables as constant. That is the thing. And I think we did 2 examples, example 418 and example 415. Basically, we just use a partial derivative. We calculate the partial derivative for each. And also, speaking partial derivatives, still we need to consider product rule, quotient rule, chain rule, those things. Okay. And how about again, let's take a break, and we will continue from here next time. I think the topic will be the next topic will be for the high order partial derivatives. Thank you very much for watching. See you next time.